Okay, so Math 12A, we are moving on to the next section in Chapter 7. We had done section 7.3. I actually haven't received any type of messages saying anyone was having trouble with it, so I'm assuming it's all going okay. Again, if it's not, you really have to let me know. It's hard not being in a classroom where I can kind of see your face and see whether you look lost or not. So you really have to, even if you're the type that doesn't tell me when you're stuck, you really kind of have to in this situation. So section 7.4 is where we are, and it will be quick because we're only going to go over one example. Section 7.4 is on something called cyclic quadrilaterals. So the first thing we have to do is we have to define what a cyclic quadrilateral is. So that was not a really good circle, but anyway, a quadrilateral just means a shape that has four sides. Could be a square, could be a rectangle, or could be any shape that has four sides. Now, cyclic, what that means is that all of the corners to the quadrilateral, my dog is going insane, just a sec. Wicket, what are you doing? Come here, come here. Is that what that means? Cyclic means all of the corners of the quadrilateral are at the edge. Wicket, come. Okay. So Wicket's going to help me draw a cyclic quadrilateral. So a cyclic quadrilateral could look something like this, where all of the corners are at the edge of a circle. That's a cyclic quadrilateral. Now there are, of course, some theorems about cyclic quadrilaterals. There's not very many of them though. One is that opposite angles are supplementary. And remember that supplementary means that they add up to be 180 degrees. Yes, add up to be 180 degrees. So opposite angles, so this angle and this angle would add up to be 180 degrees. The exterior of a cyclic quadrilateral is equal to the interior opposite angles. So again, if this extended out here, this would be an exterior angle because it is outside of the cyclic quadrilateral, so we'll call this A. It would equal B plus C, interior opposite angles added together, all right? So it's the same idea as a triangle. A triangle is very similar to that. Or sorry, is equal to the interior opposite angle, my apologies. So it's not, so A would equal C. My apologies. A would equal C. All right. Those really are the same. And you have to keep in mind the rules that we learned in the last section. The idea that two inscribed angles subtended by the same arc are equal. A central angle subtended by the same arc as an inscribed angle. The central angle is 2 times bigger than the inscribed angle. Those all still apply as well. So we're only going to do one example together, and that's it, because really it's the same as what we've been doing. We're just adding a dimension into it with the cyclic quadrilaterals. So in example 2 on page 416, they have a circle, and they have a line kind of going like this. They have a center, and from that center it comes out like this. Then they have this coming down, and this coming down, and this going across. Kind of looks like this. This is A, B, C, D, and and E. And again, they label this O because it represents the center of the circle. So they tell you that this angle is 110, and they tell you that this angle is 40, and they want us to find OAB. OAB. So they want us to find this. Let's call it X. They want us to find BCD. BCD. They want us to find this. So let's call it Y. And they want us to find BCE. BCE. So they want us to find this. We'll call it Z. Now, you may have different reasoning than someone else, but your reasoning may be fine and their reasoning may be fine. Now it says, show your reasoning. Really, all I want is if you add a couple of angles together, tell me that. Different things like that. It doesn't have to be super detailed, and you don't have to write out any theorems. So, some things I know. I know that Z plus Y are going to have to equal 180 degrees because that's a straight line. So I know that whatever Z is and whatever Y is, they should equal 180 degrees, right? And based on what we talked about earlier, this exterior angle is equal to the interior opposite angle. So Z should equal X plus 40. I know that. Again, if we were doing this in a class scenario, I'd be getting you guys to tell me all this stuff, but you're not here, so I can't, and Wicket doesn't want to talk. So, let me see. So what else could I know out of here? Well, I also know, let's think about this. This is the center of a circle. So I'm going out to the edge. So this is a radius, and so is this, which means this side and this side are equal, which means this little triangle right here is an isosceles triangle. And I know in an isosceles triangle, the angles opposite the equal sides are also equal. So I know that this angle plus this one have to equal 180 degrees. So I already have 110, which means I need 70 more. So whatever this is plus whatever this is has to be 70. So 70 divided by 2, because they're going to be equal, 70 divided by 2 is 35. So X is 35 degrees. I know this is 35, and I know this is 35. So I know that X is 35 degrees. All right? So I figured out one thing. And I know that X plus 40 has to give me Z. I figured that out down here. And if X is 35, then 35 plus 40 gives me 75. So Z is 75 degrees. And I know that Z plus Y is 180. So 75 plus Y is 180. So Y is 180 minus 75. So Y is 105 degrees. So you can see I didn't really show a whole lot of work, but I did at least show where my logic came from, so that if someone was looking at this behind me, they could kind of see where my thought process was. It doesn't have to be in detail, but you do need to show me something. Because I can tell you that on a test, if I give you a question like this and you have to find, Wicket, and you have to find 3 angles, that could be worth maybe 6 points, maybe even 9 points. If you don't show me any work and you tell me that Y is 90 degrees, I have to take off all 2 or 3, however many that was worth. Whereas if you did 180 minus 75 and you told me that was 90, I just know you screwed up in your subtraction and you don't really lose a whole lot. Okay, so that's really it. That's the whole lesson for today. I'm going to give you some to try. Please make sure that you are trying them. Don't just assume you're going to get them. I really find for most people, these take practice. They took me a long time to clue into. One thing I find is that once I get one angle, the rest kind of fall into place, but it can really take me a little while to figure out what do I know? What can I figure out first? All right? So those are some strategies that I use. Figure out one thing and then see where it leads me. All right? So we'll talk to you again soon. Bye.